This is chapter 8, number 15. Using Lewis symbols, diagram the reaction between magnesium and oxygen atoms to give the ionic substance MgO. So magnesium is in group 2, so it has 2 valence electrons right here. And so we'd put 2 dots on it. And then it's going to react with oxygen, and so we'd put oxygen right here. Oxygen is in group 16, so it's got 6 valence electrons. 1, 2, 3, 4, 5, 6. I'll draw it that way. And then we'd put an arrow like this. And then to show the transfer or sharing of electrons, we'd have one go over here to give oxygen 7, another one going over here to give oxygen a total of 8. So then we'd end up with the Mg right here with positive 2 charge, 2 less electrons. And then technically we'd put that in brackets, I guess. And then we'd have it with the O right here, and that would have 2, 4, 6, 8 electrons around it, and it'd have a minus 2 charge. But as you look now, it would have a complete octet of electrons right there as MgO. So we can see that 2 electrons are transferred when this happens from the magnesium to the oxygen. The atom that loses electrons is the magnesium, and the one that gains electrons is the oxygen. Next is 8.19. In this one, we have to draw some electron configurations for each of the following ions and determine which ones possess noble gas configurations. And in letter A, we have strontium plus 2. So strontium's right here, and so then when it's plus 2, it has 2 less electrons. 1, 2, so it's going to look like krypton. So if we write the abbreviated version, it would just be brackets Kr, and yes, it does have a noble gas configuration. It has the configuration of krypton because it has 2 less electrons than it normally would. The second one is titanium plus 2. Titanium's on the periodic table right here, and remember when transition metals gain or lose electrons, they always lose electrons because they're positive. It loses the S and the P electrons from the highest energy level. So if we'd write titanium normally, it would be argon, and then it would be 4s2, and then 3d 1, 2. And the ones that we'd lose are the 4s's, and we'd lose 2 of them because it's positive 2. And so its configuration would be argon 3d2, which is not a noble gas configuration. So remember, it always uses the highest energy level S and P electrons before it dips into any of the D's. Letter C is Se minus 2. So Se is right here, element 34. It's got a minus 2 charge, so that means it gains 2 electrons. 1, 2. It would look like the element krypton. So we just write it Kr like this with brackets around it, and then yes, it does have a noble gas configuration. And then 19D, nickel plus 2, and I with a little plus 2 charge right here. So nickel's located right here. So if you'd normally write the electron configuration, it would be argon 4s2, 3d 1, 2, 3, 4, 5, 6, 7, 8. So argon, and the 4s2s would fill, and then we'd have 3d8. And since it's plus 2, it has to lose 2 electrons, and the ones it loses are the 4s electrons first. So it does not have a noble gas configuration because it's got these 3d8s in it.